Do you ever wonder the speed at which a bike goes? Or a Ferris wheel turns? To explore how fast a bike goes based on how fast a person pedals, or to know the distance around a Ferris wheel in relation to time, you must know about linear and angular velocity. Velocity is simply the speed of something in a given direction. Let's start with angular velocity. Like it sounds, angular velocity deals with angles, specifically angles in a circle. Angular velocity is measured in revolutions around a circle, and one revolution is also equal to 2 pi radians. So, the equation used for angular velocity is that w, which means angular velocity, is equal to the number of radians traveled over the amount of time t. For example, the circle below is rotating at 10 revolutions per minute, and since one revolution is equal to 2 pi radians, we know that the circle is traveling at 20 pi radians per minute. Now let's look at linear velocity. Linear velocity deals with the linear distance traveled, in units such as feet, miles, inches, centimeters, or really any other linear distance unit. The equation for linear velocity is v, which equals the linear velocity, is equal to the radius r multiplied by w, which is the angular velocity of the circle. Let's look at this example of a bike. We're given that a person is pedaling at 60 revolutions per minute. That means that the pedals are turning the chainring 60 times per minute. As the chainring moves, it pulls the chain forward. And as the chain moves forward, it pulls the back cassette, or the center of the back wheel, at the same speed. That means that as the pedals move forward, the back cassette moves the same distance forward. We now know that the distance traveled means linear velocity, so we know that when two things are connected by a pulley or chain, they have the same linear velocity. Now let's look at the back wheel. So, as the cassette, or the center of the back wheel moves, it pulls on the spokes and turns the back wheel itself. Because the wheel and the cassette are connected by the same axis, the wheel rotates the same amount of revolutions as the cassette does. As we know, revolutions means angular velocity. Therefore, when two things are connected by an axis center, they have the same angular velocity. Let's connect this into our next example. Let's find the linear velocity of the chainring. We know that the equation for linear velocity is v equals the angular velocity times the radius. We know that the angular velocity is 120 pi per minute, and we know that the radius is 6 centimeters. This means that the linear velocity is going to be equal to 720 pi centimeters per minute. Now that you know how to calculate angular and linear velocities, try it sometime.